YouTube, what is going on today? Welcome to my algebra course, and in this video we're going to be talking about the laws of indices. So I'm going to be explaining what indices are and how useful they are in various aspects of mathematics. We're going to take a look at the 6 laws of indices and of course solve some examples under each and every one of these laws. So if this video helps you, don't forget to leave a thumbs up on it and subscribe to this channel for more videos like this. Let's get straight into the video. So what are indices? Indices basically tell us how many times a number or a letter multiplies itself. As you can see the example we have on the screen, we have a raised to the power 2, and over here being our base, also known as the base. The number which is being raised to a power is known as the base, and we have the index of 2, which is the power of 2. This 2 basically tells us that a is multiplying itself twice, and therefore you can see over here the result. We have a times a. So let's take a look at another example. A raised to the power 4. A raised to the power 4. So let's fix this together. What would this be? This would be a times a times a times a. This means that a is multiplying itself 4 times. Hence, you have the index of 4 over here on the a. And a over here, don't forget, a is the base. This term will be really important when we go to the laws of indices, or when we start looking at the laws, because we need to compare certain bases and all. You have a grip of it. All right. So let's take a look at another example, by this time with numbers. So assuming we have 2 raised to the power 2 plus 3 raised to the power 3 plus 4 raised to the power 2. We have to solve this. We have to evaluate this without using a calculator. So we know that 2 raised to the power 2 means that 2 is multiplying itself 2 times. So therefore we are going to have over here 2 times 2. And we know that 3 raised to the power 3 means that 3 is multiplying itself 3 times. And therefore, we are going to have 3 times 3 times 3 plus, we know that 4 raised to the power 2, or 4 as a base with an index of 2, means that 4 is multiplying itself 2 times. So we have 4 times 4 over here. We can solve this easily now. We have 2 times 2, which is 4. We have 3 times 3 times 3, which is 27. And we have over here 4 times 4, which is 16, and therefore if you put all these together we get 47. All right, I'm gonna write this here. 47 as a final answer. So that's basically what indices are. It's just the power to which a number or a letter is being raised to. Oh, and I think it's important to mention that indices can either be integers or fractions. So in the example above, we took a look at indices in forms of integers. So this 3 raised to the power 3, these are all integers, but we also have forms or cases where we can have indices to be fractions. For example, if you have a raised to the power 1 over 2, this is very popular. We know this corresponds to the square root of a. If you have a raised to the power 1 over 3, we know this corresponds to the cube root of a. If you have a raised to the power 1 over 4, we know this corresponds to the 4th root of a, and so on. So this is very popular. I just thought I should mention it. And this can also be very useful in one of the laws. We'll come to it in a later part of this video, but I just thought I should mention it because if you have like maybe an example like a raised to the power, for example, 2 over 3, you can represent this as the cube root of a squared. And this is very important. We'll just take a look at it in a later part of this video. So why are the laws of indices so important to us? So in mathematics, indices are really important because we see them everywhere. In trigonometry, we have some indices over there. In logarithm, we have some indices over there. In calculus, we have some indices over there. So it's very important to know the laws of indices to be able to solve a lot of mathematical problems. So I promise you that if you get to understand the 6 laws of indices, the 6 main laws, of course, you have some other 2 that I'll give to you as a bonus at the end of the video. But if you get to know these 6 main laws of indices, your life will be so much easier. I promise you that. Now, to the laws of indices, we have the multiplication law, the division law, we have the brackets law, also known as the powers of fours law, we have the negative indices law, the power of 0 law, and the fractional indices law. So we're going to take a look at the multiplication law to start with. Yeah, so the multiplication law states that if indices are multiplying each other and they have the same base, this is very important, they should have the same base. If you have the same base, you write one of the bases and then you add the exponents or the powers. So you can see over here, for example, this states the law. This is the law over here. These two indices are multiplying each other. We have a raised to the power n times a raised to the power m. So they have the same base, which is a. So you write one of the bases, which is a, of course, and then we add the exponents, which is n plus m. And very important also, if you have coefficients present, we have to multiply the coefficients. So the bases have to be the same. If they are coefficients, we have to multiply the coefficients also. Let's write down a simple question. We have, assuming a raised to the power 2 times a raised to the power 4. So these two are multiplying each other. And of course, the bases are the same. A is equal to a. So we have to just write one of the bases, you're right? And then we add the exponents in this case. So our final answer will be, you guess right, a raised to the power 6. So a raised to the power 2 times a raised to the power 4, according to the laws or the multiplication law of indices, to be precise, is a raised to the power 6. Now let's rewrite this question so I can show you exactly what I mean when I say if there are coefficients, you multiply the coefficients. So I'm just going to rewrite this. Like I said, a squared times a raised to the power 4. And in this case, let's say a squared has a coefficient of 2 and a raised to the power 4 has a coefficient of 3. So what do we do in this case? You're right. We multiply the coefficients. So 2 times 3. And then what do we do next? You're right. We write one of the bases and then we add the exponents. So in this case, this is going to result to 2 times 3, which is 6. And then we write one of the bases, add the exponent, which is 2 plus 4, giving us 6. Our final result or final answer, 6. A raised to the power 6. Division of indices. This law basically states that if you're dividing indices and the bases are the same, the bases should be the same. Very important. Unlike the multiplication of indices, you write one of the bases and then you subtract the indices. So you have to subtract the indices. You don't have to add, you subtract the indices. So let's take a look at this live in action. We're going to use a similar example like before, but this time in a division form. So I'm going to use a raised to the power 4 divided by a raised to the power 2. So in this case, what do? You're right. You write one of the bases and then you subtract the exponents. So a raised to the power 4 divided by a raised to the power 2 is a raised to the power 2. So we write one of the bases over here and then we subtract the exponent, giving us this result. And just like in the multiplication law, if you have coefficients, this time we don't multiply, we divide. Let's see this live in action with the same example, but this time with coefficients. So we have a raised to the power 4 over a raised to the power 2. And this time, let's say we have coefficient 6 and 2. So what do? You're right. We divide the coefficients. And then we write one of the bases and subtract the exponent. So we have over here 6 divided by 2 is 3, right? And then you write one of the bases, subtract the exponent, what do you get? 2. So our final answer will be 3a raised to the power 2. Powers of powers law. This law is pretty straightforward. It just states that if you see an index in a bracket being raised to a secondary power, which is m in this case, all you have to do is write a base and then multiply these two powers. Let's see an example. So if you have a raised to the power 2 in a bracket, really important, being raised to the power 3 again, having a secondary power of 3, all you have to do is write a and then 2 times 3. So you just multiply these two over here. You multiply these two powers over here, 2 times 3. But it gets really interesting when we have a coefficient, like you can see over here. I said, if coefficient is present, and very important, inside a bracket. If the coefficient is inside a bracket, then it's affected by the secondary power. So let me show you an example to make this clear. Let's take this question again. We have a raised to the power 2. And in this case, let's say we have a coefficient of 2, all in the bracket being raised to the power of 3. In this case, our result is going to be, You guessed right. These two is going to be affected. So we're going to be having 2 raised to the power 3. Then a, using the power of powers law, 2 times 3 over here. So these two is multiplying this. 2 times 3. So we are going to have 6. So our final result is 2 raised to the power 3, a raised to the power 6. But in the case where the 2 is outside the bracket, it does not get affected by this coefficient, this exponent over here. So if the 2 is outside the bracket, it does not affect it. So this exponent only affects whatever is inside this bracket. It doesn't matter whatever it is, it affects anything inside this bracket. So in this case, our result is going to be 2 a raised to the power 6. So like I said, it doesn't matter whatever is inside this bracket. You can also have b raised to the power 3, c raised to the power 4, and maybe a raised to the power 2 if they all have a secondary exponent of 3. In this case, what are you going to do? You are going to write the base, that's b, and then you multiply this by this. What do you get? You get 9, right? And then you write c, the next base. You multiply this by this. What do you get? You get 12, all right? And then you multiply this by this. What do you get? All right? You get a raised to the power 6. The law of negative indices. So this law is pretty straightforward. All it says is that if you have a situation where the power has a negative attached to it, all you have to do is divide 1 by the base affected. So you have to reciprocate the affected base. Here, affected is really important. It's supposed to be a keyword. It's really important, the affected base, because you can have bases that are not affected. For example, if you have maybe 2a raised to the power minus n, let's just use this example again. Let's just use this over here again. If you have this 2 is not affected. So this 2 over here is not affected by this n. There is no bracket. So therefore, all you have to do is to keep these 2. So you keep the 2. This is going to be equal to 2. You keep it and you multiply it by 1 divided by the affected base. This is the affected base. So the affected base is a. And then you rewrite the exponent. You make it positive. So once you reciprocate it, it becomes positive. So if the base is not affected, you do not have to reciprocate it. It has to remain intact. So the final answer here is going to be 2 over a raised to the power n. So let's just pick a normal example without any base or without any differentiation in affected base and unaffected bases. I just wanted to show you guys what an affected base was and what an unaffected base also is. So let's take another example. Maybe I'll just take a raised to the power minus 3. So in this case, what are we going to do? You guessed right. We are going to write 1 to reciprocating in this time round. So we divide 1 by the affected base. And what's our affected base over here? Our affected base is a. So affected base is going to be a. We divide by affected base, and then we make the exponent positive. So the positive exponent, we are going to get 3. So this is our final answer. A raised to the power minus 3 is the same as 1 over a raised to the power 3. So like I showed you over here, this is really important. You should be careful if there is an affected base. If it's not affected, you have to leave it out. So let me show you an example of an affected base. So this base is unaffected. So let me show you an example of an affected base. So let's say let's pick the same example over here. We have 2a, then there is a bracket. So mostly if there's an affected base, you would see a bracket. So an affected base, 2a raised to the power minus 3. So this means that, like in the previous law, like the powers of powers law, this minus 3 is affecting whatever is inside the bracket. So what are we going to have in this case? We are going to have 1 divided by the affected base. In this case, was affected base. All this here is affected base. So the affected base is 2a. And then what do we do then? We have to write the exponent in a positive form. So you have to make it a positive form this time, and we can also rewrite this as 1 over 2 raised to the power 3 a raised to the power 3. This is the same as this. Yeah. The power of zero law. This is by far the simplest of all the laws of indices. It states that any number, any variable, any constant raised to the power 0 results to 1. So, end of discussion, nothing more. If it doesn't matter how big the number is or what the variable is. If you have x raised to the power 0, the answer is 1. If you have y raised to the power 0, the answer is 1. If you have 36,566,877,000,000 raised to the power 0, the answer is 1. It doesn't matter how big it is. The fractional law of indices. This is a really interesting law, and it states that if you have a situation where the base has a fractional index or a fractional power, we can represent it in a very special way. And pay attention over here. We have in every fraction, like we have the numerator and the denominator. And in this case, in this special way they're representing it, the numerator becomes the inward power or the immediate power, the primary power, and the denominator or the rest becomes the outward power, which is usually 1 over the denominator or something like that. Let me show you in a question form or in numerical form so you know what I'm talking about. We have a raised to the power 3 over 2 as an example. So we can rewrite this as a raised to the power 3 times 1 over 2. So just to make it clear, this is the numerator, which is 3, and this is the rest, which is usually 1 over the denominator. So this is the same form, and we can also rewrite this like we saw in the brackets law, the power of powers law, like we looked at before. We can rewrite this as a raised to the power 3 in a bracket 1 over 2. So still the numerator as the primary and the rest, that's 1 over the denominator, as the secondary. And when this happens, we can then change this to, the square root of a number is equal to 1 over 2. So 1 over 2 is usually the square root. So we can rewrite this as a raised to the power 3 as a square root. So square root of a raised to the power 3. This is our final answer. And in case we have maybe something like this, a raised to the power, let's say 2 over 5, right? Or yeah, let's say 2 over 5. In this case, we can do the same thing. We expand, we write 2 times 1 over 5. We expand again, we write a raised to the power 2, and then 1 over 5, 1 over 5. And then we can write the fifth root. So this is the fifth root of a raised to the power 2. That's the final answer. So if you have 1 over 2, that's the square root. If you have 1 over 3, that's the third root or the cube root. If you have 1 over 4, it's usually the fourth root. And then it goes on 1 over 5, the fifth root, and so on. So that's how it usually is. Normally, you are just left with 1 over something after you take away the numerator. So it's pretty simple. I hope this is a bit helpful. So like I promised at the beginning of the video, I was going to give you extra laws of indices, and these are the 2 extra laws of indices I was talking about. So normally we are dealing with, throughout all the 6, we were dealing with similar bases. So we had like A, then we had like different indices. But this time we have similar indices and we have different bases. How do we tackle this equation then? Or how do we tackle this problem then? So with this law, if you have the same index and different bases with multiplication, what you do is you write the index outside the bracket and then you multiply the bases. So it's self-explanatory, I can imagine, but let's put it in a numbers form so you know exactly what I mean. 3 raised to the power 2 times, let's say, 4 raised to the power 2. So we have over here similar indices, and over here we have different bases. So let's solve this real quick. It's going to be, you guessed right, 3 times 4, and then we write the common index, which is 2 in this case. So our answer is going to be 3 times 4 raised to the power 2, which is 12 raised to the power 2. So this is our final answer. And similarly, for the division aspect of it, so if you are dividing instead, and we have different bases but similar indices, we write the bases, or we divide the bases, and then we write just one index. So let's show this in a numerical form. So we take the same question, or maybe we just flip it a bit. Let's do maybe 6. So 6 raised to the power 2 over 4 raised to the power 2. In this case, what are we going to do? To guess right, we are going to divide the bases, and then we write just one of the indices. So in this case, our final answer is going to be 2, and here is going to be 3. So we are going to get 3 over 2 or squared, or we're going to be 3 squared. If you want to like apply the knowledge from before using this brackets law, if you want to apply that knowledge, of course you can make it 3 squared over 2 squared, which is 9 over 4. So there's a final answer. So we can confidently say that 6 raised to the power 2 over 4 raised to the power 2 is 9 over 4, or 3 raised to the power 2 over 2 raised to the power 2. Now let us solve some questions. So you can either pause this video and try to solve the question by yourself, or we can do it together. So this over here, we are going to use, you guess right, the bracket rule to open this bracket. So the power of powers rule, according to that, we can rewrite this as a raised to the power 2, b raised to the power 2, c raised to the power 2. So over here, we have 1, 1, 1. We just don't write them. So 2 multiplied by 1 is 2, 2 multiplied by 1 is 2, and so on. That's why we have 2, 2, 2 over here. And then we do the same for the denominator. We also have the bracket rule over here. So we have to multiply this 3 by this 3 by this 3 outside by this. So if we do that, we are going to get a raised to the power 2 times 3, b raised to the power minus 1 times 3, c raised to the power minus 3 times 3. So you just multiply each and every one of these powers by 3. So further, we are going to get, in this case, a raised to the power 2, b raised to the power 2, c raised to the power 2, and then 2 times 3 is 6. So it's a raised to the power 6, and we have b minus 1 times 3 is minus 3, and we have c minus 3 times 3 is minus 9. So this is what we have. This is what we have now. Now we want to separate each and every one of these according to the same basis, because you know we have to deal with the same basis. We can't subtract this and this, unless of course they have a similar index. Then we can just work around like I showed you in the bonus tips. But for now, we have to separate all of them, put them into different categories. So we can rewrite this statement over here as a over 2 divided by a over 6 multiplying b over 2 divided by b raised to the power 2 divided by b raised to the power minus 3 times c raised to the power minus 2 divided by c raised to the power minus 9. So this over here, this statement over here is the same as this. So you can rewrite it as this. Actually, if we multiply, we get this. So now we can simplify. So what do you do next? You guess right, we use the division rule. In the division rule, we write one of the bases. We have similar bases over here. So you have to just write one of the bases and then subtract the indices. So let's do that right now. We have a as the base. We start with a, and then we subtract the indices. 2 minus 6. We do the same for b. 2 minus 3. We do the same for c, which is 2 minus 9. I just put this in bracket to differentiate it a bit. And then we can just do the further simplify it over here. So we have a 2 minus 6 is minus 4. We have over here b 2 minus 3, which is the same as 2 plus 3, which is 5. And then we have c, which is the same as 2 minus 9, which is 11. So in this case, we have further simplified it over here. So we can either use the another law over here. I don't know if you know what law we use over here. You guessed right. We use the negative index law over here because we have, it's not necessary. You can leave this as a final answer, but it's also nice if you change it a bit, and then you can rewrite this as either a raised to the power minus 4, b raised to the power 5, c raised to the power 11, or you can write b raised to the power, b raised to the power 5, c raised to the power 11, all over a raised to the power 4. Both of these answers are correct. Let's try out another question. So with this statement right here, we are supposed to simplify this, and then once it's in the simplified form, we then input these values in, so we evaluate it. That's what this means. That's what this question means. So we're going to start off by first simplifying it. So you guessed right. We are going to separate them like we did in the previous question. We're going to separate them into categories like we did. So you have to rewrite this as a raised to the power 5 over a raised to the power 2 times b over b raised to the power 3 times c raised to the power 3 over c raised to the power 2. This is not necessary, just for clarity. You can just write it straight away. You can write the answer straight away once you become more proficient. But for clarity's sake, I'm just going to leave it like this. So we go on then to write one base. We write one base and then subtract the indices. So this is the division rule. So we write one base and we subtract the indices times b, write one base, the first base, and then we subtract the indices 3, 1, the first base, and we subtract the indices 3 minus 2 is always from the top to the down, always top to down, numerator first, denominator second. So 3 minus 2. So our simplified version is going to be a raised to the power 3 times b raised to the power minus 2 times c raised to the power 1, which is also c. This time we can then evaluate. It's in a simplified form, or we can just maybe use the negative index rule to change this, but it doesn't really matter. We're going to do it anyway. So we can now evaluate. We can then fix in these values inside a simplified version. So let's do it now. A is 3 over 2. So we're going to write a, just going to write 3 over 2 instead of a. So 3 over 2 raised to the power 3 times, what's b? B is 1 over 2. So we're going to write 1 over 2 raised to the power minus 2 times c. C is 2 over 3. So it's going to keep it like that. And then we are solving further. So we can then expand this using the bracket rule or the power of power rule. You got it right. So using the power of power rule, we are going to now open this bracket. So it's going to be 3 raised to the power 3 over 2 raised to the power 3 times, we do the same here, but this time we are going to use the negative index rule. Now the negative index rule, what we have to do is to divide the affected. If you remember, we have to divide the affected base, or we have to divide 1 by the affected base, if I should put it correctly. So 1 over 2, or we reciprocate it, so it becomes 2 over 1. But it's better if you just write it maybe 1 over 2, just for clarity's sake. And then 1 over 2 is also 1 divided by 1 over 2. And we can also rewrite this as 1, and multiplication time. So we reciprocate 1 times 2. And this is equal to 2. So it's just the same thing. You reciprocate, or you write, so that you reciprocate it, or you divide it by, you divide 1 by 1 over 2. So we're just going to clean this up. And then we saw what happened. So we're just going to write over here 2, but raised to the power 2. We reciprocate it, and then we make the index positive. So 2 raised to the power 2 times 2 over 3. So this remains the same. So we're going to open this up. We're going to expand this. We're going to write the answer for this. So, you know what? I think we could do it in a more interesting way. We could also then put them together and then factorize them again and use the laws of indices to play around it. But I think maybe it's better if you just write the answer straight away. So if you have 3 raised to the power 3 is 27. 27 divided by 2 raised to the power 3 is 8 times 4 times 2 over 3. So in this case, you can just go ahead and divide. So we have 4 here, 1, 4 going to 2. We have 2 here, 1, 2 going to here, 1 as well. And we have 3 goes into here 1, and 3 goes into here 9 times. So our answer becomes 9 times 1 times 1, which is equal to 9. So 9 is our final answer. Or let's just do it the other way around, what I was suggesting. So let's say we had 3 raised to the power, what's that, 3 raised to the power 3, 3 raised to the power 3, and 2 raised to the power 3, I guess. 2 raised to the power 3 times 2 raised to the power 2 times, was it 3 over 2? 2 over 3. 2 over 3. We could also do it another way and also utilize or practice the laws of indices. So we can group it now. We try to group it together. So we have 3 raised to the power 3 times 2 raised to the power 2 times 2 all over 2 raised to the power 3 times 1 times 1, because the denominator over here is 1 and over here is, oh, over here is actually 3, not 1. So we have 3, so the denominator 3, and over here is 1, so we're just going to keep it 1 over here. So now we can group it together and use the laws of indices to simplify this. So using the laws of indices, we can further simplify this. We know over here we have the product rule or the multiplication rule. So we can just do the multiplication. We have the same base, so we just add the indices. What do we get at the top? We have now, we have now 3 raised to the power 3 times 2, 2 plus 1, just like this. And we have over here to 3. We can just leave this 1 out actually. We have over here 3 times 2 raised to the power 3. So in this case, we can further go on to say we can group them now, because we can see we have groupings here. We can group them now. It's a long process, but just for the explanation's sake. And 3 raised to the power 3 over 3 times 2 raised to the power 3 over 2 raised to the power 3. So this cancels itself, or we can also do it in a really interesting way and utilize the 0 or power of 0 rule. We can use 2 raised to the power 3 over 2 raised to the power 3. So to simplify further, we can write one of the bases, which is also 3, and then it becomes 3 minus 1 times 2, and then 3 minus 3. Over here we get 3 raised to the power 2 times 2 raised to the power 0. And according to the power rule or the power of 0 rule, any number raised to the power 0 is 1. So you got it right. Here is going to change to 1. We're going to have 3 raised to the power 2, which is also 9. I'm just going to write it straight away. And here is going to be 1. So the final answer is going to be 9. This is a longer process, but it's just trying to utilize the laws of indices and see various aspects. So this is also another way you can do it, but this is a longer process. You don't have to do it like this. I'm just doing this for clarity's sake. So question number 3 is going to be a little assignment. You should try this out, and I'm excited to see your answers in the comment section below. So if you've come to the end of this video, if you really liked it, don't forget to leave a thumbs up on it and subscribe to this channel for more videos like this. And also, if you have any questions, thoughts, suggestions, videos you want me to cover, do what to leave them in the comment section below. So next time, Black, and I'm out.